Alright, so in chapter 3.2, we're going to be solving linear systems algebraically. In this lesson, you will learn about two methods for solving linear equations algebraically, and the two methods are listed below. Remember, in the previous section, we had looked at how to solve equations by graphing. Here, we're going to learn about the elimination method, also known as the linear combination method, and then the substitution method. Alright, so let's go ahead and start off with the substitution method. And we're going to solve the linear system by substituting one of the equations into the other. Now this method works very well when one of your equations only has no coefficient, meaning that the coefficient is 1. If you have coefficients, then for each variable, it's easier to use the second method, the elimination method. So because this one has x plus 2y equals to 2, we can quickly go ahead and solve for x. And if we do that by subtracting the 2y on the other side, then what we can do now is substitute. What we can do now is substitute the value, the expression, into the previous equation. Now the reason why we can do that, remember that the x, when you have a solution to a linear system, the x values are the exact same. So the same with the y values. So that means because x equals this expression, it will also equal the same in the previous or the first equation. So let's go ahead and substitute that into the equation. I'll write it over here. We have 3 times, instead of x, we're going to write that expression, negative 2y plus 2. And then we're going to have plus 4y equals to negative 4. So if we expand, or if we distribute into that expression, we have 3 times negative 2 is negative 6y. 3 times 2 is 6. And then we add that on to 4y, and that will all equal to negative 4. Alright, so we can collect the like terms together. Because we have negative 6y and 4y, that will give us negative 2y plus the 6 equals to negative 4. We can continue collecting like terms by subtracting 6 on both sides, and we have negative 2y would be equal to negative 10. Dividing both sides by negative 2, we would get y is equal to positive 5. So now that we have y equals to positive 5, because that y works for both equations, we can substitute it into either of the formats we have here. Typically, we substitute back into one of the original equations. And so we could just do it into this one here since it already says x equals. So we have x equals to negative 2 times 5 plus 2. And so x is going to be equal to negative 10 plus 2, and x is equal to negative 8. All right, and so there we have it. We have the solution. The solution to this linear system is negative 8, 5. And if we were to actually graph this, what you see here, if I erase, I'm just going to erase everything there. If we erase everything, we get our negative 8, 5. Our x is negative 8, and our y is 5. All right, so let's solve the linear system here. If we were to do one in the elimination method, or the linear combination, that's what it's called in the book, what we do is we eliminate one of the variables. And to do that, we typically need to change just one or both of the equations so that the variables are the same. And we could do that by using the lowest common multiple and then just multiplying it by the number or the multiple that would get us there. And so if you look here, if we were to multiply this 2x by 2, it would become 4x. And then we can cancel it out by subtraction. And that's exactly what we're going to do. Since we notice that we can multiply one of the equations to change it, we can do that and work it out. So we're going to multiply this by 2, the whole row. Just times that by 2. And we're going to rewrite the new equation below. So we're going to have 4x subtract, right? 2 times 2 is 4. 2 times negative 4 is going to give us that 8. Y equals to 13 times 2 is 26. So that, remember what we learned before, they can be multiples of each other. And because they're multiples of each other, we can use that concept to eliminate. All right, so we'll keep the other equation below. 4x subtract 5y equals to 8. Now the steps are in the book, so you can always look at the book again. But we're going to go ahead and subtract, right? We're going to, and it could be addition or subtraction. So typically what you want to do is just look at what you have. You could multiply this by negative 2, and if you do that, it will change all your signs, and that way you can just have one rule. just multiply by the opposite sign of the number you're trying to get it to, and then always add. That's one of the easiest way to remember the rules. So if we add these together, negative 4x plus negative 4x, it's going to cancel. The 8 plus, because we're adding the whole way through, 8 plus the negative 5 is going to give us a positive 3y. And the negative 26 plus the 8 is going to give us a negative 18. If we divide both sides by 3, then we're going to get y is equal to, well, negative 18 divided by 3 is going to give us negative 6. And we get our y value. Then we could take this y value and substitute it into one of the original equations. You could choose whichever one looks easiest. And I think the 2x, since it's smaller, might be the easier one. So we have 2x subtract 4 times our y that we just got, negative 6, equals to 13. And this will now allow us to solve for x. So we have 2x. We know it's going to be a plus sign here because of the double negative. 6 times 4 is going to give us 24 equals 13. We can collect the like terms. So we have 2x is going to be equal to 13, subtract 24. And so 2x is going to equal, therefore, to 11. It looks, yeah, 11, negative 11. And then we're going to divide both sides by 2. So x is equal to negative 11 over 2. As a mixed number, 2 goes into 11 5 times with 1 left over. So negative 5 and a half. And if I was to graph this, what we should see is that we will have a unique solution, an intersection, and at that intersection we're going to see negative 5 halves and negative 6. And that's exactly what we see. And if I clear the screen one more time, so you can see it clearly, that's our solution. So we can solve it graphically by seeing where they intersect, or we can solve it algebraically. All right, what happens now if we have to do both of them? Sometimes it's not as easy just to multiply one equation. The same way with fractions. When we're adding fractions, sometimes we only need to multiply the denominator of one fraction. Other times we have to multiply both of the fractions so that the denominators can be equal. Same concept here. Sometimes we have to multiply both equations in order for us to properly cancel using the elimination method. And so for this one, you want to choose a number that you can easily cancel. So you'll look between the 7 and 5 and the 12 and 8. It doesn't matter which one, it's just which one would be easier to do. Between the 7 and the 5, they're harder numbers to have something in common. You have to multiply them by each other, 5 and 7. But if you do that, you get bigger numbers. So if you look at the 12 and the 8, you see that they both can go into 24. And that means that you can multiply both equations by smaller numbers or smaller values. So if you multiply the top one to get to 24 would be 2, and the second one multiply the whole equation to get to 3, then the middle terms will be 24. And because the signs are opposite of each other, you don't have to multiply by a negative. When you add, they will cancel out. And so remember, the other key is to always make sure you have the opposite signs. Okay, so let's go ahead and simplify this. If we do that, the first row, 2 times 7 is 14x. 2 times the negative 12 is going to give us negative 24y. It's going to be equal to 2 times negative 22 is negative 44. 3 times the negative 5 is going to give us negative 15x. 3 times that's going to be positive 24y, and 3 times 14, that's going to give us 42, I believe. All right, so now that we have that, we could go ahead and combine our linear equations here by adding them. This will eliminate the middle term, and since we added in the middle, we're adding everywhere else. So 14 plus the negative 15 will give us negative x equal to negative 44 plus positive 42 is going to give us negative 2. And the two negatives on either side is going to make us have x equals to positive 2, as we could divide both sides by negative 1 or multiply both sides by negative 1. So we get x equals to positive 2. We could take the x equals positive 2 and substitute it into either of the other two equations. Let's go ahead with the first one. It has no negative in the front, so 7 times 2, right? That's what our x is. Subtract 12y is equal to negative 22. All right, so just that was a negative 22, so we have 14 minus 12y is equal to negative 22. To get the y by itself, you can bring that 14 over as a negative 14. And that's subtracting the 22 that's there. And that's going to give us 36. So negative 12y is equal to negative 36. Dividing both sides by negative 12 is going to give us y equals to negative 3. And so we have here, and that's a negative 12, so a positive 3. So we have positive 2 and positive 3 there. And that's exactly what you see if we were to graph these. This is the graph of the two lines as we done in the previous examples. And that's our solution graphically, 2, 3. So you can either do it algebraically or graphically. All right, so here's an example with no solutions. Some reason I have the graph already up. So to do this one, you see that they are parallel lines. That's because these are multiples of each other, and these two are not the same. Remember, we learned that before. That means that they're parallel. It means the slopes are equal, but their y-intercepts are not, and that means they're parallel. But just to show what that would look like if we were to solve it, you can see that if you multiply this one by 2, then you would get 2x subtract 4y equals to 6, and then we have here 2x subtract 4y equals to 7, right? And that would have been better as a negative. So if I do a negative 2, now we can just add everything together. And so negative 2x plus 2x is going to cancel out. This would also cancel out too, right? 4 subtract 4 cancels to 0. And so we have a 0 there. And then on the right side, we have negative 6 plus 7 is 1. Because 0 cannot be equal to 1, that means that this is never will be true. No matter how many times you do this, this cannot be true. And so because it cannot be true, there is no solution between those two equations. And if there's no solution between those two equations, then they are parallel. All right, so if you get an untrue statement, remember that means there's no solution, means they are parallel, they have equal slopes, different y-intercepts, and you can show that by if you change these into the slope-intercept form. All right, the last one here, the infinitely many solutions, and remember with infinitely many, you'll notice that every term that's here is a multiple of the terms in the other equation. And so we can always tell that by just simply figuring out what you can multiply one of the equations by, or what you could divide one of the equations by. What we could do is just simply use the LCM, finding the lowest common multiple that they can all multiply into. And just at a first glance, you can see that in the first two, they both multiply into 30, whereas the second one, they multiply into 50. And so you could choose which one you want to go into. If you choose these two, you try to get these to be 50 and multiply everything else the same. If you try to get the other two terms, you multiply those so that you can get them to become 30. Either one is fine with what you do there. But I'm going to choose the other one here. We're going to multiply this so that they become 30, so that is smaller values. So we're going to multiply to get 6 into 30, we have to multiply it by 5. And actually, that's just going to work off of both because they're parallel. So if we times this one by 5, and we're going to times this one, and they're already opposite signs, we're going to times this one by 2. And when we do that, in the first equation, we will get 30x subtract 50y is equal to 60. All right, the second one, we're going to get negative 30x plus 50y equals to negative 60. All right, so this cancels, and this one cancels as well. And so we're left with 0 equals to 0. Now, it's different from the other one. This is a true statement. And not only is it a true statement, you might remember this as being the identity. And because we get the identity here, that means it's always true. And if it's always true, it is always true for every single point on the line. And so the graph shouldn't have been there yet. It simply means that they're an infinite amount. That means 1 could be 1, 2 could be 2, right? There's an infinite amount of solutions there, And when we have an infinitely many solutions, it means we have a single line. It literally means it's the same line. And that means because that line goes on forever in either direction, we have an infinite amount of solutions. All right, so in this one, this is taken from the book. Forgot to put the site there, but it's explain how you can tell whether the system has infinitely many solutions or no solutions without trying to solve the system. Well, we talked about that in the previous section, and hopefully you remember that. So how would you? Well, you can look at to see if they're multiples of each other. Remember, both of them have to be multiples, but the one that has no solution, the constants are not multiples of each other. So if you look at this one, you can times everything by 2. So 2 times 5 is 10, or if you do negative 10, and you see that because everywhere can be multiplied, it means it's actually the same line in slope-intercept form. And because in slope-intercept form it would be the same line, this one would be infinitely many solutions. Of course, by deduction, the other one is no solutions. But the way we can tell is that only these two are multiples of each other and not the 8 and the 12 in terms of direct multiples. So if I multiply this one by 3, negative 2 times 3 is negative 6, 3 times y is 3y, but 3 times 8 is not 12. And so that means when you work it out, these will represent your y-intercepts when you finally work it out in slope-intercept form. And so because they will have the same slope on this side where the x's are and the y, that means that we will have the same direction, the same slope, but since the intercepts are off, then they will be parallel, and that means there would be no solution as we saw before.